So solving linear equations. So by Gaussian method, the main thing is Ax equals to b could be converted into Ux equals to c, where what solutions which are true for Ux equals to c are true for Ax equals to b. Now to attain from A to U, we need to do some reductions, which is basically making the A matrix into a reduced form which is simple to solve. That is just the main motto. So the U matrix, when the concept I learned, the U matrix was the reduced row echelon form, which by the way is unique, but we can also have row echelon form, which is much easier to get, and it's basically uh, trying to uh, see there's a matrix, and what we are trying is somehow if we could make many of the elements to zero, which is like eliminating many of the variables and forming a certain form where it's easy to find the output of that variable. Okay, so what do I mean by that? How do we do this row echelon form? We start with the pivot. The pivot is actually a concept which means the leftmost element of that matrix. The idea is below it all would be zero. That's it. Below it, below the pivot, all would be zero. And so for example, we start with making like the row 1, the pivot is the first entry. Now the next under it all we eliminate it to make it 0. Then we move to the diagonal entry, which if is 0, then we have to move horizontal and to figure out where that non-zero element is. It's so much. Yeah, so dholak noise again. So pivot, we have to move diagonal, we get if we get 0, then we have to move horizontal to find out where that non-zero element is. If we find out that non-zero element, then we move that under it all elements we make it to 0. Under it all elements we make it to 0 by again performing row operations, which is just like if row 2 minus row 3 minus row 2 is 0, then we perform that operation. Now if we see that under the next row has 0 under it, means in some cases we switch the rows. These are the cases when there is no pivot in the row we are getting and there is a pivot down it under that row, then we switch it. Through this combination we figure out the optimal matrix where it looks like we just where the pivots are, and then we solve for that equation. Now the point to remember is the number of pivots in that matrix is actually the number of linearly independent columns that exist in that matrix. Rest are actually non-independent or linearly dependent columns. Now, linearly dependent columns are also that variables means the columns correspond to a variable which are free variables, and columns corresponding to the linearly independent variables are pivot variables, which is obvious fact. So as we know from rank also, that the number of linearly independent columns is equal to number of linearly independent rows. Now, which I was speaking about, first I started with that was reduced row echelon form, which is unique by the way. There the pivot element is 1. The pivot element is 1, and under it and above it we make all zeros. There's a pivot element, and under it and above it all are 0. That is reduced row echelon form. This is unique. Row echelon form is not unique. By various combination you can get a different matrix. It depends upon how you operate. This is the first step.